Hello students, I hope you're fine. As you know, I'm Mrs. Feliciano, your elementary science teacher.
And I'm Mr. Acevedo, high school science teacher. So Mrs. Feliciano, we already saw the fourth graders, so what do we have for today?
Well, for today, we're gonna see our fifth grader exposing their science fair's experiment. So, enjoy, have fun watching it. Bye-bye. Oops.
Good morning, my name is Derek Javier Rizarri Torres. The title of my science fair project is Soap Boat and Water Magic. The purpose is how those water temperature affects its surface tension. My hypothesis is the boat will move faster in warm water. The boat will break more easily the surface tension in the hot water and will have more momentum. I read the book Química Moderna and the website Sciencing and NASA. My report is that superficial tension is the attraction between molecules. The molecules create a barrier. The heat reduces the resistance of the barrier and cold increases it. The materials used in this experiment are warm water, cold water, cotton swabs, foam paper, soap, bowl, scissors, and a cooking pot. To make this experiment, we need to cut the foam paper to make a boat like this. Warm water in the stove. Third, pour the water in the bowl. Put dish salt at the bottom of the bowl. Fifth, put the boat in the water. And finally, repeat using cold water from the refrigerator. Remember to check the result variables. The control variables are the salt, the foam boat, the bowl, and the amount of water. The independent variable is the temperature of water. The responding variable is the fact that the boat moves faster in warm water, so the surface tension is more in cold water. The first time I put the boat in cold water, it took 12 seconds to reach the end of the boat. And the second time, it took 19 seconds. In warm water, it took 1 second the first time, and 3 the second. My hypothesis was correct because the boat moved faster in warm water. The momentum in cold water was less because the molecules were closer, and the surface tension was stronger. This experiment is important because we see surface tension every day. Surface tension allows insects to walk on water. The hot water also cleans better because it has less surface tension. Detergents reduce the surface tension in water and makes it penetrate the clothes better. My investigation helped me to understand this force and see it in what surrounds me. Thanks. Good morning, my name is Carlos Yarek Irizarry Torres. My science fair project is called Walking Waters. The purpose of my project is how salt affects capillary action. My hypothesis is that salt water will go up slower than the fresh water because the salt will force the water molecules to go down. I read some websites such as NASA and study.com. I also read a book called Química Moderna. My report is that capillary action is the attraction to a surface liquid and a solid surface. Adhesion, cohesion, and surface tension allows the capillary action to occur. cohesion is water molecules stick to water molecules. Adhesion is water molecules stick to molecules such as salt. For this experiment, we used 14 cups of plastic, 12 pieces of paper towel, food coloring, fresh water, salt water, and a measuring cup. To do it, you need to create a line with the cups. Second, fill the first, third, fifth, and seventh cup with water. Third, put some drops of red food coloring in the first and seventh cup. In the third cup, put some drops of yellow food coloring, and in the fifth cup, put some blue ones. Fold 6 pieces of paper towel and put them between the cups, connecting them, just like this. Repeat the process. Instead of fresh water, use salt water. Finally, shake the spoons. My control variables, the ones that did not change, were the food coloring, amount of water, plastic cups, and napkins. The independent variable is the water. The responding variable is that the capillary action is lower in salt water than in fresh water. This is data. Here we see the changes that happened as time went by. In the end, the fresh water moved faster than the salt water. I can conclude that my hypothesis is correct. The salt affects the capillary action because it is heavier. This experiment is important because it demonstrates the importance of the capillary action. Like the plants that absorb the water and our human bodies, that the blood flows through our veins. Finally, we can see the capillary action with the paper towel that absorbs the water we spilled. Thanks.
Hello kids! Have you ever gone to the beach and asked yourself, how do waves are formed? Well, I got the answer for you. When the wind blows on the water surface of the oceans or lake, it creates friction and forms the waves. Another way waves are created, it's because of the gravitational pull that the sun and the moon have on the earth, causing and creating waves. Have you learned?
They want to experiment how to make an egg float on the water. Material: egg, salt, a container, measuring spoons, measuring cup, ruler. Salt water is denser than ordinary salt water. The denser the liquid, the easier it is for a vacuum to float in it. When you lower the egg into the liquid, it drops through the salty water. At this point, the water is then enough for the egg to float. You were careful when you added the tap water to salt water. They will not have mixed enough the egg to make them float in the middle of the glass. Now the result of the experiment. Result and interference. First, we added 2 tablespoons of salt, and it didn't float. Then we added 4 tablespoons of salt, and it didn't float. Then we added 6 tablespoons of salt, and it didn't float. Then we added 8 of salt, and it didn't float. Then we added 10 tablespoons of salt, and it didn't float. Then we added 12 of salt, and it didn't float. Then we added 14 tablespoons of salt, and it flowed 1 centimeter. Then we added 16 tablespoons of salt, and it flowed 2 centimeters. Then we added 18 tablespoons of salt, and it flowed 7 centimeters. Now the conclusion. Our hypnotist was partially correct. The egg did float in salt water, but it took 18 tablespoons of added salt. Thank you.
My name is Darren Nelson at Minnesota. Now I'm going to show you my presentation for the science fair. Which type of sponge absorbs the most water? Purpose is we are going to find out which type of sponge absorbs the most water. Which type of sponge absorbs the most water? My hypothesis, natural sponge absorbs the most water. Materials that I use is natural sponge, this is the gold loofah, artificial sponge, foam bath sponge, polyurethane, and melamine foam. What you need is water, large bowls, and measuring cup. Procedure. Take one sponge and press it inside a bowl full of water for 10 seconds. Let it drain a little. Squeeze the sponge until all of the water comes out in a measuring cup. Record this measurement. Do the same thing for all the sponges. Evaluate which one held the most water. Examine and compare the sponges and try to understand what properties might help one hold more water than another. These are my procedures. Variables. The dependent variables are the water and the materials. The dependent variables are the type of sponge, their size, and amount of times we will try the experiment. These are the results. Natural sponge, that's the gold loofah, is 1/3 of a cup, half of a cup, and half of a cup. Polyurethane, that's artificial sponge, half of a cup, half of a cup, and half of a cup. Foam bath sponge is 1/4 of a cup, 1/3 of a cup, and almost 2/3 of a cup. And melamine foam, 1/3 of a cup, half of a cup, a little over half of a cup. And these are the materials. This is the gold loofah, the polyurethane, the foam bath sponge, and the melamine foam. Conclusion. After repeating the procedure to try every sponge, the result were that the foam bath sponge absorbed the most water, meaning my hypothesis was not correct. The natural sponge did not absorb the most water. The foam bath sponge absorbed the most water. Application. In the use of different sponges, I noticed that not all of them absorb the most water the same way or the amount of time. In life, everyone is different. Not everyone have the same opportunities, but we all have a heart and a love of God. Like the sponges, we all receive the love of God, but we do not share it the same way. Unlike the sponges, we decide how to use our time, how we live our lives, and if we want God in our lives. Thank you.